Hello everyone, welcome to Automation Community. In this video, we are going to see about what is automation. Before going to the topic, please like and subscribe our channel. Let's enter into the topic. So what is automation? So there is no need of explanation, right? Even a kid know what is automation nowadays, because in our home we are using more automated devices. Example, you can say induction stove and automatic washing machine. Like that we can find more devices around us, right? Fine. So in simple, what we can call as automation? It is a self-dictated system. You can see the word automation gives the meaning self-dictating or a mechanism moved by itself or operating according to the program we have done, right? So the auto and matos means, auto means a self and a matos means moving. It is a Greek word and they have combined these two to make the word called automation. So why we have introduced automation? Mainly to replace the human operators and to improve the safety and obviously to increase the production, right? So let's move on to the history of automation. So automation was highly popularized in 1910s and 1920s. So there was a huge need of automated devices in the World War time. So that's the the requirement of automation was more than those time. So that's what it was introduced and it was used widely in that era. And you can see in collaboration with the General Motors, automation department was introduced in 1947. And the PLC, the first PLC, before it was calling as PLC, it was called as 084, and we are going to see about this PLC and the usage in the later classes. But whenever it comes to automation, a PLC is playing a vital role, which is called as programmable logic controller. So we'll see more about PLC in our later classes. And let's move on to the types of automation. So as I have already discussed about the devices what and all we are used in home will come under a home automation. And the second one is building automation, like the automation we have introduced in the building, like elevators, lift and all. And we have a industrial automation and process automation, public transport automation, where you can find the example like traffic light control. These and all come under a public transport automation. And the last one is scientific automation. Obviously for all our research and development we are using automated kits, right? So let's move on to the benefits of industrial automation. So why we are going to study about this industrial automation? Because the main invention of automation is for the industry, right? Because the production, we want to increase the production, right? So industries are our backbone. So obviously you can find more automation usage in the industry. And in our course we are going to study more about this industrial automation, and here and there we will find some examples for home automation and building automation. So what is industrial automation? So the device or the system which we are going to implement in the industry to increase production, to ensure the safety and to replace the human operators. And as we have already discussed, you can see the benefits of industrial automation here. So to increase the precision, to improve the product quality, to reduce periodic and manual checking. This is very, very important, because if you put a human operator, obviously there will be a human error, but if you put a machine over there, we can reduce the error. But obviously to make that machine we want a human, that's a different case. So to increase the consistency in output also we require a machine. So these are all the very basic benefits of industrial automation. So let's move on to the history of automation. So how it evolved. So there was a time where we were using only manual control, right? For example, let's take a boiler over there, and you have a temperature controller or a temperature indicator over the boiler. Let's take a temperature indicator. So according to the temperature value, you are going to control the flow of water inside the boiler. If the boiler is reading high temperature, you need to increase the flow of water high. If the temperature is getting low, you need to decrease the flow of the water. So there was a time we used to control this system manually. So operator have to be near the boiler and he have to continuously monitor the temperature indicator to get the value, and according to that he will change the flow of water. So there was a time we were controlling temperature using a manual control. So in this case you can find more disadvantages, right? First thing, the accuracy is very less, right? And safety is also matters when we are putting a human over a high temperature boiler, nearer to the high temperature boiler. So these are all the cases which push the man to invent something which will reduce these kind of insecurities in the industries, right? So there was one step above a manual control, there was a pneumatic control. So we were controlling the system using air pressure, and then comes a hard wire logic control, which is nothing but a relay control. So next is electronic control, which used a logic, digital devices, and over that we have a PLC and DCS control. So in each step we found more advantages and more disadvantages. So as we have already discussed, we found more disadvantages in the manual control. That's what we jumped to the pneumatic control. Then we found more disadvantages over that and we moved to the hardwire. And if you see the hardwire, there was a relay control system. If you see a hardwire relay, it is having multiple wires. You need to connect each and every logic using the wire. Fine. So if you want to troubleshoot, it will be a big headache for the operator to find out where is the fault. So this made an engineer to move to the electronic control, where we used some digital logic gates to perform the operation. So then we move to the PLC and DCS control. So let's see more about this PLC in our later classes. So, but in industrial automation, this PLC and DCS are playing a major role, right? So that's in our top, it's in the tree's top. And next we have industrial automation devices. So what is this? What are the components or devices we are going to use it in the industrial automation? So first thing is field instruments. So let's take the same boiler example. So I want to measure what is the temperature of the boiler, right? So for that I need an instrument which is used to measure the process variable. So here the temperature is the process variable. So I'll be using some temperature sensor or transmitter or a transducer to measure the temperature. So that is the field instruments the instruments which are used for the measurements. That is a field instrument. And by using these field instruments, how we are going to control? So we want some controller, right? For example, if a temperature is going above 90, I want to increase the flow of the water. That's what our case, right? So in this example, to control the flow, I need to write a program inside the controller. So those type of controller are our controller hardware. You can see a PLC, DCS or PID device or in CNC. So where I am going to write the logic, those are called as a controller. So that will be having a hardware and also a software, right? And the last one is a control software, which is called as SCADA, Supervisory Control and Data Acquisition System, which is used to monitor what is happening in the field. So it's like a visual, or you can call it as a virtual devices in the software, where you can in an industry you can find a control room in one place and a field in some other place. In control room, by sitting in a control room itself, you can monitor what is happening in the field, like a CCTV camera in the shopping hall. It's a simple example for our layman understanding. And that's it about the introduction of automation and the industrial automation. So this is again automation installation procedure. So whatever we have seen in the previous slides, field instruments, control hardware, control software, it will having this flow. A sensor placed in a field, and all the sensors and the wires will be connected to the junction box, and we are getting all the signals from the junction box to the cabinet, where we will be having our controller and IO modules. So from that we will be getting a signal to the SCADA or HMI. And you can find the picture of the field instruments over here, which is giving all the signals to the field box, and we are collecting all the signals from field box to the marshalling cabinet, and from there we will be giving signal to our controller, which is a system cabinet, and from there we are going to watch or monitor. Even we can control also from the workstation, which is nothing but our HMI or SCADA, right? So I hope you have understand the basics of automation and industrial automation. If you like this session, please like and subscribe our channel, which will motivate us to do more in industrial automation course. Thank you so much.